We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello and namaskar to all the viewers. In the continuation of previous lecture, today I am going to share how checks are done once we design the reinforcement detail for beam. Means whatever reinforcement we have provided, it is satisfied the IS criteria or not. So particular in design of beam, we need to check the spacing criteria and the minimum percentage of steel as well as maximum percentage of steel. So I have already drawn the cross section of the beam that we have already designed in previous lecture. So the width of the beam was 250 mm, effective depth was 450 mm, effective cover on both sides was 50 mm. We have provided 3 number 32 mm dia bar having tensile area of steel 2412 mm square in the tension zone, and in a compression zone we have provided 3 number 25 mm dia having area 1472 mm square. So let's see first check for spacing. Check for spacing means whatever reinforcement we have provided between 2 reinforcement bar, what is the spacing, and that spacing is satisfied the IS criteria or not, right? So for that, first we need to find out the spacing of individual bar. So for that, just take for AST center to center distance between bars is equal to, right? So we need to first, what we need to find the center to center distance between bar. So for that, total width of the beam is 250 mm and the effective cover for both sides minus 50 and minus 50 divided by the numbers of bars are 3, and to find the spacing we need to write 1 less of that number divided by 2. So we get the center to center distance divided by 2, 75 mm. And for center to center distance, just find clear distance between bars is equal to, see, what we have found out, the center to center distance is 75 mm, but we need the clear spacing. So this whole diameter is 32 mm diameter, right? So half diameter from this side and the half diameter of this side means we need to deduct one whole diameter. So in this way we get the clear distance between individual bar in tension zone, and that is 43 mm. Now we have to check this 43 mm clear spacing between horizontal bar is satisfied the IS criteria or not. For that, minimum spacing criteria is given IS 456, page number 45, close 26.3.2. So they have clearly written the horizontal distance between two parallel main reinforcement bar shall not be less than the greatest of the following. So the greatest of the following is first one, the diameter of the bar if the diameters are same. So diameter of the bar is 32 mm, and the second one is larger diameter of the bar if the diameters are unequal. See, if we have provided two different size of diameter, say one is 32 mm dia and one is 30 mm dia or 28 mm dia. So in that case, take the larger diameter. But in our case, we have provided the equal diameter. So second criteria does not come into the picture. And the third one is 5 mm more than the nominal size of the course aggregate. Just assume nominal size of aggregate equal to 20 mm. So 20 plus 5 equal to 25 mm. So why IS has recommended that clear distance between the bar must be greater than the nominal size of aggregate plus 5? Because if the spacing is less than the nominal size of the aggregate, what happens? The proper compaction can't done. That's why they have recommended that the spacing must be greater than the size of aggregate plus 5 and greatest of the following. So whichever is larger, right? And this is what? 32 mm equal to 32 mm. So IS has recommended that our spacing must not be less than 32 mm in our case. So we have provided spacing equal to 43 mm, which is greater than 32 mm. That's why. Okay. Again, I repeat. First, what you need to do is center to center distance between bar. From that center to center distance, just find the clear distance between bar. Then from IS 456 page number 45, find the three criteria. And whichever is larger among these three criteria, take the maximum of this, and our spacing must be greater than this value. So our reinforcement is satisfied the minimum spacing criteria as per IS. Now, maximum spacing criteria. So what IS has recommended, IS 456, page number 46, table 15. They have clearly written that for FE 415 grade, the maximum distance between bar is 180 mm. In table 15, for different grade of steel, they have written the maximum spacing criteria. We have to look in zero line column. For this table, we get the value of maximum spacing for FE 415 is 180 mm. So maximum spacing is equal to 180 mm, and our spacing is less than maximum spacing. That's why okay, right? So our spacing in tension reinforcement satisfy the minimum spacing as well as maximum spacing criteria. Similarly, we have to check the reinforcement in compression zone. So let's check that. For ASC, center to center distance between bar will remain same. Why? Because numbers of bars are 3. but clear distance between bar will be changed. 75 minus the diameter of the bar is 25 mm. 75 minus 25 equal to 50 mm. Okay. So diameter of the bar is 25 mm. Second is not applicable because we have provided the equal diameter, and the third criteria remains same, 25 mm. And here it comes, whichever is larger is 25 mm. And our spacing, we have provided the spacing 50 mm, which is greater than 25 mm. That's why our reinforcement detail is satisfied in minimum spacing criteria as per IS 456. Now maximum spacing criteria. For FE 415, the criteria is maximum spacing criteria is 180 mm, and we have provided the spacing 50 mm, which is less than 180 mm. So it is okay. Means our reinforcement detail, our spacing details in compression zone as well as the tension zone are satisfied as per IS criteria. So in this way, we can check the minimum spacing as well as maximum spacing. Now we will check the minimum percentage of steel as well as maximum percentage of steel. Check for minimum percentage and maximum percentage of steel. First, minimum percentage of steel. Now for AST equal to, we have 2412 mm square. So in IS 456, page number 46, 47, they have given the criteria for minimum reinforcement or minimum percentage of steel AS upon BD equal to 0.85 upon Fy. So AS equal to 0.85 BD upon Fy. 0.85, width of the beam is 250 mm and the effective depth is 450 mm and the Fy is 415. 0.85 into 250 into 450 divided by 415. 230.42 mm square. So what does this mean? 230.42 means what IS has recommended. If width of the beam is 250 mm, effective depth of the beam is 450 mm, and the steel grade used is 415, then in that beam, area provided means area of reinforcement minimum must be 230 mm square, and we have provided AST is equal to 2412 mm square, which is greater than 230. That's why okay. See, IS has recommended that for this given dimension and the given properties of steel, area must be minimum of 230.42 mm square, and we have provided 2412 mm square, which is greater than minimum. That's why we have whatever we have provided, it satisfies the IS criteria. That's why okay. Now minimum percentage of steel for ASC. Let's check for ASC also. ASC, we have provided 1472 mm square. So the minimum AS area of steel will remain same. Why? Because width, depth and steel grade is same. So we have provided 1472 mm square, which is greater than 230.42 mm square. That's why okay. So our reinforcement detail satisfied IS criteria in both compression zone as well as tension zone reinforcement detail. Now, maximum percentage of steel or maximum AST. So, as per IS criteria, page number 47, what they have mentioned, maximum area of steel is 0.04 B into capital D. 0.04 B is 240 and the capital D is 500 is equal to 5000 mm square. See, okay. For AST equal to, and we have provided AST 2412 mm square, which is less than 5000 mm square. That's why okay. And for ASC 1472 mm square, which is less than 5000 mm square. That's why okay. So what does this 0.04D means? It means 4% of cross-sectional area. So IS has recommended that we can provide the maximum percentage of steel, these cross sections 4% only. More than that, we can't provide. So whatever reinforcement we have provided or we provide, area of that reinforcement must not exceed the 4% of the cross-sectional area of the beam. And in both the cases, AST and ASC, I mean in tension zone and in compression zone, whatever reinforcement we have provided, that satisfied in maximum percentage of steel as well as minimum percentage of steel. So this is the way that we have checked the minimum spacing as well as maximum spacing between horizontal bars and the minimum percentage of steel and maximum percentage of steel bar after providing the reinforcement in the design of doubly RC beam or singly RC beam, right? So with this, I conclude my session. Thank you.